Definition. A reference angle is just an acute angle associated with theta and the x-axis. So this is going to be really important that we are able to find reference angles. Let's look at this coordinate plane. If we think about it, let's think about it in terms of quadrants. So here's my first quadrant. Here's my second quadrant going counterclockwise. This is my third quadrant. There's my fourth quadrant. And we know that this is 0, 90, 180, 270, radians, and then I'm back to 360. Let's do radians. So 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, so if I'm trying to figure out what an acute angle associated with theta and the x-axis is, my first quadrant, if you think about that, between 0 and 90 degrees, well, an acute angle is less than 90 degrees. So anything in the first quadrant is going to be an acute angle. So if I'm looking for a reference angle and my angle is in the first quadrant, the reference angle is itself, because all those angles are acute. If I'm in the second quadrant, well, this is between 90 and 180. So I'm looking for the reference angle, the acute angle associated with theta and the x-axis. So I'm looking, my x-axis right here, what I'm associating that with is 180 degrees or pi. So if I'm looking for theta, if I've got theta, I'm just going to subtract theta from 180, and that's going to give me an acute angle. That's going to give me the reference angle. Okay? Then if I'm in quadrant 3, I'm basically doing the same thing. I'm looking at my x-axis, or 180 degrees as my reference. But instead of subtracting theta from 180, I'm going to subtract 180 from theta, because theta is going to be bigger than 180 in this third quadrant. And then the fourth quadrant, still important that you associate this with the x-axis, and the angle there is 360. So to find my reference angle there, I'm going to subtract theta from 360 degrees. Alright, so let's do a couple of these. If I'm looking for the reference angle of 175 degrees, well, I need to think about what quadrant that terminal side lies in. So 175 degrees is going to be in quadrant 2. So to find that reference angle, I am subtracting theta, which in this case is 175, from 180. So 180 minus 175 degrees is going to be 5 degrees, which is easy enough. Alright, let's look at another one. So 10 pi over 9. Alright, where is that? Well, 9 pi over 9, 9 pi over 9, or pi, would be right there. So this is a little bigger than that. So I'm looking at quadrant 3, which means that I'm going to subtract my theta. I'm going to subtract theta minus 180, or if I'm in radians, from pi. Okay? And if I'm doing this, I'm going to get a common denominator, which is 9, so I'm going to multiply the top and the bottom by 9, and then just subtract straight across. So that's going to be pi over 9. So pi over 9 is my acute angle. It's my reference angle for 10 pi over 9. The other thing you can do if you don't like dealing with that is, like I said in an earlier video, just go ahead and change this to degrees. So 10 pi over 9, if I change this to degrees, I'm multiplying by 180 over pi, and if I simplify that, well, that turns out to be 200 degrees. Alright, and you should see that clearly. We already said this was in quadrant 3. I'm going to find my reference angle. I'm just going to do 200 minus 180, or 20 degrees, which is the same thing as pi over 9. That's your preference. Okay? One more thing we need to know before we get started in what we're doing next is the signs of trig ratios. Now notice how this is spelled signs. So we're looking at whether they're positive or negative. Alright, so if you just go back to what you learned in algebra and think about if I were plotting an ordered pair, or if I'm looking at x and y and their signs in each of these quadrants, remember that if I go over to the right and up, that's going to be positive. So my x value is going to be positive, my y value is going to be positive. Also remember in an earlier video, I dropped a triangle to show you that, and I won't confuse you, I'll use theta there, that the x is cosine of theta and that y is sine of theta. So if I'm looking at this trig ratios in the first quadrant, if I know that sine is positive and cosine is positive, well then tangent's going to be positive because tangent is sine over cosine, and all the reciprocals are going to be positive. So all 6 trig ratios are actually positive in that first quadrant. Now let's look at the second quadrant. The second quadrant, x is negative, but y is positive. Alright, y, remember, is sine of theta. So sine of theta is going to be positive in that second quadrant, and its reciprocal, of course, is going to be positive. Alright, in this third quadrant, x is negative, y is negative. Negative over a negative. Well, x is going to be negative, so cosine is going to be negative. Y is going to be negative, so sine is going to be negative. But if you remember, tangent is sine over cosine. A negative divided by a negative is a positive. So tangent of theta is going to be positive in that third quadrant, and it's reciprocal. And then the fourth quadrant, x is positive, y is negative, which means cosine is positive, and its reciprocal is positive. And there you go. So I sort of explained all that, but really what you just need to remember, I remember an acronym. I always remember all seniors take calculus. All seniors take calculus. That's how I remember. And like I said, it's going to be important because when we find exact trig values, depending on what quadrant there are, it's going to determine the final sign at the end.